In this video, you're going to create your first asynchronous non-blocking program, which means your app is going to continue to run while it waits for something else to happen. In this case, we're going to stick with a really basic example, but in this section, we're going to be building out a weather app that communicates with third-party APIs like the Google API and a weather API. We're going to need to use asynchronous code to fetch data from those sources. Before we get into any of that though, in this video, we're going to go over a basic example of asynchronous programming, and in the next one, we're going to talk about what happens behind the scenes when you run asynchronous code. That video, coming up next, will give you a really good idea about how your program runs, what tools and tricks are happening behind the scenes to make it run the way it does. For now though, all we need to do is make a new folder on the desktop for this section. I'm going to navigate onto my desktop and use mkdir to make a new directory, and I'm going to call this one weather-app. All I need to do before I switch to Atom is navigate into the weather app. Perfect, and I'm going to use clear to clear the terminal output. Awesome. Now we can open up that new weather app directory inside of Atom. This is the directory we'll be using throughout this entire section. In this video, we're not going to be building out the weather app just yet. We're going to be playing around with the async features. So inside of weather app, I want you to make that playground folder. This code is not going to be part of the weather app, but it will be really useful when it comes to creating the weather app in a couple of videos. Now, inside of playground, we can go ahead and make the file for this video, async-basics.js. Awesome. I'm going to close this untitled tab and we can get started. To illustrate how the asynchronous programming model works, we're going to get started with a really basic example using console.log. Let's get started by adding a couple console.log statements in a synchronous way. Nothing new here. We're going to create one at the beginning of the app that's going to say starting app. And we can add a second one to the end. Down below, console.log, and this one will print finishing up. Awesome. Now these are always going to run synchronously. No matter how many times you run the program, starting app is always going to show up before finishing app. In order to add some asynchronous code, we're going to take a look at a function that Node provides called setTimeout. Set, capital T, timeout. SetTimeout is a great method for illustrating the basics of non-blocking programming. It takes two arguments. The first one is a function. This is going to be referred to as a callback function. It's going to get fired after a certain amount of time. And that's the second argument. It's a number, the number of milliseconds you want to wait. So if you want to wait 1 second, you would pass in 1,000 milliseconds. Let's go ahead and call setTimeout, passing in an arrow function as our first argument. This is going to be the callback function. It's not going to get fired right away. It's going to get fired after the timeout is up, after our 2 seconds. Then we can set up our second argument, which is the delay, 2,000 milliseconds, which equals those 2 seconds. Inside of here, all we're going to do is use a console.log so we can figure out exactly when this function fires, because the statement will print to the screen. Console.log, and something like inside of callback will get the job done. Inside of callback. Awesome. Now with this in place, we're actually ready to run our very first async program. And I'm not going to use nodemon to execute it. I'll show you why in just a second. I'm going to run this file from the terminal using the basic node command. Node space playground, and the file inside the playground folder is async-basics.js. Now pay close attention to exactly what happens when I hit enter. Right away, 2 messages show up, then 2 seconds later, our final message inside of callback prints to the screen. Right away, we got starting app. Basically, immediately after that, finishing up prints to the screen, finally inside of callback. Over here inside of the file, this is not the order we wrote the code, but it is the order the code executes in. Starting app prints to the screen as you expected. Down here, we call setTimeout, but we're not actually telling it to wait 2 seconds. We're registering a callback that's going to get fired in 2 seconds. This is going to be an asynchronous callback, which means that Node can do other things while these 2 seconds are happening. In this case, the other thing it does is it moves down to finishing up. Now, since we did register this callback by using setTimeout, it is going to fire at some point in time. And 2 seconds later, we do indeed see inside of callback printing to the screen. Hopefully this makes a little bit of sense. By using non-blocking I/O, we're able to wait, in this case 2 seconds, without preventing the rest of the program from executing. If this was blocking, we would have to wait 2 seconds for this code to fire, then finishing up would print to the screen. And obviously that would not be ideal. Now, obviously, this is a pretty contrived example. We're not exactly going to be using set timeout in our real-world apps to create unnecessary arbitrary delays, but the principles are the same. For example, when we fetch data from the Google API, we're going to need to wait about 100 to 200 milliseconds for that data to come back. And we don't want the rest of the program to just be idle. It's going to continue on. We're going to register a callback, and that callback is going to get fired once the data comes back from the Google servers. The same principles apply, even though what's actually happening is quite different. Now, in order to wrap this video up, I want you to write another set timeout right here on line 7. I want you to register a set timeout that prints a message, something like second set timeout works. That's going to be inside the callback. And I want you to register a delay of 0 milliseconds. 0. No delay at all. Then go ahead and run the program from the terminal and see exactly what happens. How'd it go? Hopefully you were able to run the program and maybe you saw something that didn't quite make sense. Let's go ahead and fill out the async basics set timeout. I'm going to call set timeout with my arrow function, passing in a delay of 0 milliseconds. Awesome. Inside of here, I'm going to use console.log so I can see exactly when this function executes, and I'm going to use second set timeout as the text. Now that we have this in place, we can go ahead and run the program over from the terminal. And it's really important to pay attention to the order the statements print. I'm going to run the program. Right away, we get 3 statements, and then at the very end, 2 seconds later, we get our final statement. We start with starting app, which makes sense. It's at the top. Then we get finishing up. After finishing up, we get second set timeout, which seems weird because we clearly told Node, hey, we want to run this function after 0 milliseconds, which should run it right away. But in our example, second set timeout printed after finishing up. Finally, inside of callback printed to the screen. This behavior is completely expected. This is exactly how Node.js is supposed to operate. And it's going to become a lot clearer after the next video where I go through this example exactly, showing you what happens behind the scenes. We're going to get started with a more basic example, showing you how the call stack works. We'll talk all about that in the next video. And then we're going to go on to a more complex example like this one that has some asynchronous events attached to it. I promise the reason why second set timeout comes up after finishing up is going to be very obvious after the next video. I'm super excited to get to it, so stay tuned. I will see you then.